Okay, so we need to consider the situation where two circles touch. Okay, now one situation is where they touch externally. Okay, in other words, the two circles will occupy their own space. Okay, but they will touch at one point, and we can show that they touch if we simply compare the distance from both centers to the radius of both of them. Okay, so what should happen when they touch is that the distance from the centers will equal to the sum of the two radii. Okay, so in other words, the d there will equal to r1 plus r2 when they touch externally. Okay, now if they don't touch, one possible scenario is this. Okay, you've got one circle sort of inside another circle. Okay, now the distance from the centers there, okay, won't relate to the two radii. Okay, there won't be any connection between them. Okay, so we've got to sort of compare them carefully to see if they touch. And our focus now is going to see if they touch here externally. Okay, let's look at A here. Okay, so we've got two circles here, and in the first circle I'm going to write down the center of it. Okay, so the center is -1, 2. Okay, yeah, going from there, so that's my AB, so -1, 2, and the radius will equal to 2. Yeah, so we're going to square root the 4 there to get the 2. Okay, and we've got our radius. So with the second circle, then the center will be 3, 5, and the radius will be the square root of that, which is 9. Square root of that, which is 3. So what I'm going to do then is I'm going to work out the distance from the two centers. Okay, so the distance will equal to, so remember now, using that distance formula, okay, so we'd have 3 take away -1 there, all squared, and then 5 take away the 2 there, all squared. So when we work that out, that comes to actually 5, right? So the distance from the two centers is 5. Now, if you look at the radius of both of them, when you add them together, that also comes to 5, doesn't it? So we have that situation there where the distance between the two centers, okay, is equal to the sum of the radii. Okay, so therefore circles touch externally. Okay, so we have this situation here essentially, okay, where the two radii added up to distance between them. Okay, let's look at a second example, right? So we've got here the center to be -4, -1 in this case, yeah? Looking at AB there, and radius will be the square root of that, so the radius will be 5. Here then the center will be 8, 4, okay, and the radius will be the square root of that, so the radius will be 12. Okay, so you can see the distance, when you add them together you get 17. Let's see if the distance between these two is 17. So the distance, well, let's just go straight for it. So x2 is 8, take away x1, which is -4, and then my y2 is 4, take away my y1, which is -1. So we get here, that will be, that's obviously turns into a positive. Okay, when you work this out you end up getting 13. Now distance is 13. If you add those two radius together, okay, you get 17. It's 17 when you add the two radius together. However, the distance between the centers is only 13. Okay, so it looks more like the second situation that we've got here. Okay, you've got to see if there's any way you can connect these numbers, because we'll see in the next question that circles can actually touch internally as well, but there's no way you can connect these numbers here. You can't take one of them away, whatever, to equal the other one. Okay, so we've got the situation like that there, essentially, in this case, where the distance here is 13, and then you've got the two radii, okay, and they don't connect to each other. So we can say here circles do not touch.